right, now we're moving from linear to quadratics. Okay, so we're switching gears a little bit. Okay, a quadratic is a second degree polynomial, which I know sounds foreign, but you can know that an equation is, or you can name equation based on its highest exponent, and a quadratic's highest exponent is that 2. So anytime you have that x squared in there, and that's the biggest one you've got, that means it's a quadratic. All right, standard form of a quadratic looks like y equals ax squared plus bx plus c. All right, and when we're working with our quadratics, once we get down to the quadratics, you typically want them in standard form when you're factoring. Okay, we have 4 ways of factoring that we're going to look at today. Okay, factoring is the opposite of multiplying, right? So if we wanted to do 2 times 3 to get 6, okay, that means that my factors of 6 were 2 times 3. Okay, so factoring is the opposite of multiplying. All right, so the first thing that we're looking at, and what you should always look for first, no matter what, whether it is a quadratic, or if it is a cubic, or if you have 20 terms, no matter what, you always look for a GCF, because we are trying to completely factor these equations. Okay, so for the first one, we got 9x plus 36. A GCF is your greatest common factor. So we're looking for something that goes into both 9x and 36. A shortcut is always start with the smallest number, because your GCF can't be bigger than the smallest number, because then it wouldn't go into that smallest number. So I'm going to start with the 9. All right? 9 goes into itself, and 9 also goes into 36. So I'm going to take out that 9. All right, they don't both have a variable, so I can't include that variable in my GCF, but I'm going to go ahead and take out a 9. I'm going to put it on the outside of parentheses. When you take out a GCF, you divide by that GCF. So 9x divided by 9 is just 1x, or just x. And then 36 divided by 9 is 4. All right, you can always check your factoring, because if you multiply, you should get back to where you started. So if I want to check this one, and I wanted to distribute that 9 times x is 9x, 9 times 4 is 36. So I know I factored correctly. Okay, for the second one, all right, start with the smallest one. We got 6x cubed minus 3x to the 5th. So I'm going to start with my 3. Right, 3 goes into itself, and it goes into 6. So that means I can take out a 3 as part of my GCF. But this time, they both have x's, right? Since they both have the x, that means I can take out at least a portion of x's, right? And your shortcut with the variables is you always take the smallest exponent. So these both have x's, and they both have 3 x's, right? Because this first one, x cubed is x times x times x. X to the 5th is 5 x's, so they both have 3 in common. So that means I'm going to take out my x cubed, and again we divide. So 6 divided by 3 is 2. I have 3 x's. I took 3 out, so I don't have any x's left. Right? Negative 3 divided by 3 is just a negative 1. All right, and I'm going to wait to put my 1 in there. And then I have 5 x's, and I took 3 out. So that means I have 2 left. So I'm just going to leave that as x squared, right? And I waited to put my 1, because if there, is a variable, I don't need to write the 1 in there. But if there's no variable, then I would put the 1. All right, if you take out a big enough GCF, if you take out the correct GCF, the numbers inside parentheses won't have anything left in common. So here I have a 2 and a 1. They have nothing in common except for 1, which goes into everything. All right, and then they don't both have a variable, so there's nothing else I could have taken out here. Okay, so you can check your work that way too. All right, for number 3, we've got 3 terms. So again, I'm going to start with the smallest one. So I'm going to start with 14. Obviously, it goes into itself, but 14 does not go into 21. So that means 14 can't be my GCF, but my GCF still has to be a factor of 14. So I'm going to start working my way down. The next biggest number that goes into 14 is 7, and 7 goes into 21, so that means 7 is going to be my GCF. Okay, and then they all have variables. They all have an x, so I'm going to take the smallest x, which is this first one, x to the first power. Then we divide. 14 divided by 7 is 2. I had an x, but I took one out, so there's no x's left. 21 divided by 7 is 3. I had 2 x's, but I took one out, so that leaves me with 1. Right? Then 21 divided by 7 is 3 again. I had 3 x's, I took one out, so that leaves me with an x squared. All right, we can double check. They don't all have variables, so I took out the correct variable. And then 2, 3, and 3 don't have anything in common. 3 and 3 do, but it has to be in common with all the different terms in that expression. All right, and then one more for GCF. Okay, I've got, 8, 24, and 12. So I'm going to start with the 8. 8 does go into 24, but not 12. So I've got to get smaller. So the next biggest number that goes into 8 is 4. 4 goes into 8, 4 goes into 24, and 4 goes into 12. So I'm going to have to take out a 4. Now, with GCFs, you always keep the sign that's out front. So like for all the ones we've done so far, I had a positive number out front. So I have a positive GCF. But here, I have a negative. So I'm going to make my GCF a negative 4. Okay, and that's going to switch it up a little bit when we start dividing. All right, and then they all have x's, and my smallest x is x to the 5th. So that's going to be my GCF. So I got negative 4 x to the 5th. So now, because I'm taking out a negative, pay attention to signs. All right, so for the first one, I have negative 8 divided by negative 4. That's a positive 2. I had 7 x's. I took out 5, so that leaves me with 2. So I have x squared. Then I have a positive 24. I have a positive 24 divided by a negative 4, so that's going to be a negative 6. All right, and then I have 6 x's. I took out 5. That leaves me with 1. And then I've got a positive 12 divided by a negative 4, and that's a negative 3. I had 5 x's, but I took all 5 out, so I don't have any left. All right, we can double check. They don't all have variables, so I took out the right variable. And then 2, 6, and 3 don't all have something in common. So 2 goes into 6, 3 goes into 6, but 2 and 3 can't go into each other, so we don't have any other GCFs there. All right, so always, always, always look for GCF first. The next pattern, all right, depends on what you're working with. In order to do difference of squares, I have to have 2 things. So difference means subtraction, right? And then squares is talking about perfect squares, right? And our perfect squares are the numbers that we can take the square root of and get a nice pretty number. So for example, 9 is a perfect square because the square root of 9 is 3, right? 16, 25, 36, 49, all of those numbers are perfect squares because I can take the square root and get a nice pretty number. Our pattern, if I have 2 perfect squares, right, because a squared and b squared are going to be perfect squares regardless of what number they are, and I have subtraction, then I use the following pattern. We say that it becomes, right, 2 parentheses. I take the first square root, which would be a, plus the second square root, and then the first minus the second. So we have 1 plus and 1 minus in our parentheses. Now it looks kind of weird, but it'll hopefully make a little more sense when we start doing them. All right, so for the first one, I have x squared minus 1. X squared is going to be a perfect square because it's x to the second power, it's x squared. And then 1's a perfect square, right? The square root of 1 is 1. And then I have subtraction, so I can do difference of squares. So the square root of x squared is just x. All right, the square root of 1 is 1, and then I plug them in. We have x plus 1, x minus 1. Okay, it does not matter if you do the plus, then the minus, or the first. That part doesn't matter. Okay, for the second one, we've got 9x squared minus 4. Okay, so 4, my square root's 2. 9x squared looks a little weird. Think about them separately. The square root of 9 is 3. The square root of x squared is x. So I have a 3x and I have a 2. So we have 3x plus 2 and a 3x minus 2. Okay. All right, for number 3, we've got subtraction. 16 is a perfect square, 49 is a perfect squared, and so is x squared and y squared. Okay, so another thing you can look for with variables and exponents, as long as you have an even exponent, that's going to be a perfect square. So I've got a 2 and a 2, so we're good with our variables. All right, the square root of 16 is 4. Square root of x squared is x. Square root of 49 is 7. Square root of y squared is y. And then we plug in. So I've got a 4x plus 7y and a 4x minus 7y. Okay, for number 4, okay, I've got 2x squared minus 8. Now, x squared is a perfect square, but 2 and 8 are not. What on earth am I going to do? Well, this goes back to what we talked about first. The first thing you always have to look for is a GCF. So 2 goes into both 2 and 8. So I have to start by taking out that 2. Okay, so if I divide by 2, 2 divided by 2 is 1. So I'm left with just x squared. And then negative 8 divided by 2 is a negative 4. All right, now x squared minus 4 looks better. The square root of x squared is x. The square root of 4 is 2. So I'm going to have x plus 2 and x minus 2. All right, now we're not quite done yet, because if I multiplied these, if I did FOIL, right, and I'm going to get back to x squared minus 4, not 2 times x squared minus 4. So anytime you have a GCF, that's got to follow you all the way down to your final answer. Okay, then the last one, we've got x to the 4th and 16. 4 is even, so that we're good there, and then 16 is a perfect square. So the easy one here is the square root of 16. That's 4. Okay, if I have something besides x squared, like x to the 4th here, to find the square root, you cut the exponent in half. So I have an x squared. So that means I have x squared plus 4 and x squared minus 4. Okay, now I put this one on here for a reason. You've got to make sure you factor it completely. All right, so what I mean is that this first one, I have x squared and I have 4. Those are perfect squares, but I don't have subtraction. So I can't do difference of squares again, so I'm done with that one. But over here, I've got subtraction. So that means I can do difference of squares again. So you have to always look to see if you can factor more. So the square root of x squared is x, 4 is 2. So this part becomes x plus 2, x minus 2. And then I got to bring down my first parentheses, x squared plus 4. All right, so this is a factored form, but completely factored is down here. All right, so you've got to make sure if I get down to x to the first power, I don't have to worry about it. But if I have any exponents, you got to double check and see if you can keep going. Okay, our next way of factoring, get my paper set up here, is trinomials. Okay, so trinomials means we got 3 terms going on, right? And we've got 2 types of trinomials that we consider. The first one is what I call plain Jane, right? That's not really what they're called, that's just what I call them. Okay, and plain Jane trinomials means that a equals 1. Now that a that I'm talking about comes back from what we said standard form was. So we have ax squared plus bx plus c. So that a is the number in front of the x squared. So if that a is a 1, it looks like this. 1x squared plus 5x plus 6. So you have an x squared term, an x term, and then a constant. All right, so that's our plain Jane trinomial. To factor plain Jane, we look for 2 numbers. All right, we got to have 2 specific numbers. Okay, I'm going to go ahead and go to my parentheses. All right, plain Jane, I can go ahead and put my x in the parentheses. Then I look for 2 numbers that multiply to our c term and add to b. So again, let me write our standard form up here for us. So I'm looking for numbers, right? I have a 1 for a, so I don't have to worry about that one. I want to multiply to get our c term, and I want to add to get the b term. Okay, and once I figure out those numbers, I can just write them in my parentheses. So the first one I'm going to do kind of quick. 2 numbers that multiply to 6. It's either 1 times 6 2 times 3, or that's it, yeah. Let me write it over here. So we got 1 times 6, 2 times 3. Those are my factors of 6. I want to add to 5, so that means my numbers have to be 2 and 3. So I have a plus 2 and a plus 3, and that's it. There's my factor form when I'm working with plain Jane trinomials. Okay, so it's always going to be that kind of pattern. The tough part's figuring out your numbers. Okay, so for the second one, I'm going to go straight to my parentheses, right? But this one's a little different. Okay, if I'm working with all positives in my equation, I have all positives in my answer. That's an easy one. But here, I got this -7 in there. All right, so I'm going to ignore that -7 for just a second. I want to find two numbers that multiply to 12. So my options are going to be 1 and 12, right? 2 and 6, and 3 and 4. Those are all my factors of 12 when I multiply. All right, now in order to multiply to a positive 12, I either have to have a positive times a positive or a negative times a negative. Right, so that means I either have to have two positives, two negatives. It'll be the same sign if I have a positive C value. Right, to get to a negative number, the only way I can add negative numbers in terms of having two positive or two negative is if I have two negative. Right, so anytime I have a negative B value, both of my factors have to be negative. Okay, so here, if I have positive, they're both going to be positive because everything's positive, right? But here, both are going to be negative. So as soon as you have a positive, that's important too. As soon as you have a positive C value but a negative B value, both of these are going to have to be negative. All right, so now that means I'm going to make these negatives. Okay, then I add, I got to see which one's going to give me -7. So -1, -12, that's -13. -2 and -6, that's -8. But then -3 and -4 is going to give me a -7. So I have -3, -4. Okay, then for 3 and 4 here, we got like the opposites going on. So I have two negatives, and then here I've got a positive and then a negative. So I switched it up. So first step, always go straight to your parentheses. Okay, now I'm looking for numbers that are going to multiply to a -8. If I'm going to multiply to a negative number, I have to have one positive, one negative. All right, so that means I'm going to have a plus and a minus. And then I have to think about all my numbers twice. Okay, so my factors of 8 are 1 and 8, 2 and 4. But because I have one of each, that means I have -1, +8, -2, +4, and then 1, -8, and 2, -4. So I have 4 options now. Okay, I want to add to a -2. -1 plus 8 is 7. All right, -2 plus 4 is +2. 1 plus -8 is -7. 2 plus -4, that's going to be my -2. So that means I have a +2, -4. Okay, now for number 4, oh my goodness, I don't have A equals 1. I got this 2 in there. Right, well, the first thing we always have to look for, GCF, right? So 2 goes into itself, it goes into 18, and it goes into 20. So I'm going to take that 2 out. So 2 divided by 2 is 1, so I'm left with 1x squared. 18 divided by 2 is 9, so we have 9x. And then -20 divided by 2 is -10. Well, by taking out that 2, now I have my plain Jane trinomial. I just made it way easier on myself. All right, so I'm going to go straight to my parentheses and go ahead and bring my 2 down because it's got to stay with the final answer. All right, now I want to multiply to a -10. Okay, so that means I got to have one of each. So I'm going to have a -1, +10, -2, +5, and then a 1, -10, 2, -5. All right, so I've got -1 plus 10. There's my 9 right off the bat. So I have a -1 plus 10. Okay, so that's if it's plain Jane. Multiply to C, add to B. Plain Jane means you can go straight to your parentheses and then just find your numbers to plug in there. The last thing we're going to look at is if that A isn't 1. So the first thing, if A isn't 1, you should be looking for that GCF. But sometimes you don't have a GCF. So we're going to have to do what we call, or what I call, bottoms up. Now, You may have learned an X method for factoring. That is perfectly fine, or the butterfly method. I don't even know what they're all called. Use whatever method you want as long as you can factor it. I'm going to show you a shortcut that I learned that I really like and think it's easy, and you get the right answer every time if you do it right. Okay, so bottoms up has 4 steps, right? The first thing we have to do, like again, I don't have a GCF to take out, so make sure of that first. But if right now I can't do anything because of that 3. So what I want to do is get rid of that 3, and I'm going to get rid of it by moving it and making it part of 5. All right, so I'm going to take my 3, and I'm going to move it over here just for a minute. All right, so my first step is to multiply by whatever a is. Okay, so then my new equation is going to be x squared minus 2x, and then 3 times negative 5 is a negative 15. All right, by doing that, by getting rid of that 3, now I've got a plain Jane trinomial, what we just did. So that means I can factor that guy really quickly, right, as long as I can come up with my numbers. So my second step is going to be to factor the plain Jane trinomial, right? So that means I'm going to put my x's in here. Okay, I'm looking for numbers that are going to multiply to a negative 15 but add to a negative 2. Let me change colors so I can jot my numbers down. So I have to have one of each. So we've got negative 1 and 15, and we got 1 and negative 15. Then I got 3 and negative 5, negative 3 and 5. And I want to add to that negative 2 in the middle. Right? So negative 1 and 15 is 14. 1 and negative 15 is negative 14. 3 and negative 5, there's my negative 2. So I'm going to have a plus 3 and a minus 5. But I'm not done. This factored the x squared minus 2x minus 15, not the beginning one. And I have to figure out what multiplies to get that beginning expression. So the first thing to do is to move the a. That means now I have to take the a back out. So I moved it by multiplying. So to take it back out, we're going to divide. So I'm going to divide a. And I'm going to divide a divide these two numbers by a, because these two numbers are what made up my c value, right? Where I moved it, that's where my 3 was. So now these two numbers are what got me there. So I'm going to divide these by whatever my original a was. Then we simplify. So 3 divided by 3 is 1. 5 divided by 3, I can't do. I can't simplify that. That's as simple as it gets. So then my last step is to do bottoms up. So I take anything that's on the bottom and I move it up in front. So that means I'm going to have x plus 1 times 3x minus 5, because we don't leave any fractions in our factored form. So to start with, we move a by multiplying, then we factor, and then we take a back out by dividing. Then we simplify, and then we do bottoms up. Alright, so I promise it's not that long once you get the hang of it and you start moving. So let me change colors and we'll do the second one. Alright, no GCF, nothing goes into 2, 11, and 5. So I'm going to start by moving that a. So I'm going to multiply and move it over to be part of c. So then I have x squared plus 11x, and then 2 times 5 is 10. Now it's plain Jane. Alright. I want to multiply a 10 but add to 11, so I'm going to go a little quicker. That's going to be 10 and 1. Alright, then I'm going to divide by a. So I'm going to divide these by my original 2. Simplify. 10 over 2 is 5. And then 1 over 2, I can't simplify. That one just stays 1/2. Okay, then my last step, anything that's on the bottom, move up. So I have x plus 5 and 2x plus 1. Okay, let me change colors again for our third one. All right, so for our third one, I do have a GCF. You've got to look for a GCF. All of these numbers are even, which means 2 goes into all of them. So the first thing I'm going to do is take out that GCF. Always, always, always. All right, so 12 divided by 2 is 6. 10 divided by 2 is 5. And then negative 12 divided by 2 is negative 6. Okay, I still have to do bottoms up, but if I did it from the beginning, I wouldn't get down to my simplest factored form or completed factored form. All right, so the 2 is going to be part of my final answer. Don't forget about that guy. But I'm going to kind of ignore him for a minute and do my factoring here. So step 1, I'm going to start by multiplying my a and making it part of c. So I have x squared plus 5x minus 36. Okay, then I'm going to go to my parentheses with my x's. I want to multiply to negative 36, but add to 5. That's going to be a plus 9 and a minus 4. Okay, then I'm going to divide by my original a, which my original a was 6, right, because I took the 2 out. So I'm going to divide by 6 and simplify. 9 over 6 simplifies to 3 over 2, and 4 over 6 simplifies to 2 over 3. And then the last step, bottoms up. Now I have 2 fractions, which means I have 2 things on the bottom that I have to move up. That's okay. Okay, so this one's going to be 2x plus 3. And this one's going to be 3x minus 2. Not quite done. Got to bring down that 2. That 2 is part of my final answer.